Okay, so 6.5 is called dividing polynomials. Okay, so in 6.1 we did adding and subtracting of polynomials. 6.2 we multiplied polynomials by FOILing. 6.3 and 6.4 we've expanded and then factored. So 6.5 naturally is dividing polynomials. Okay, so I'm going to show you two different ways to divide polynomials. Okay. So the first way is going to be called synthetic substitution. Okay, and I'm going to actually scroll down. So if you guys are following me on OneNote, I'm going to scroll down all the way down till we get to the assignment part. I feel like it's just easier to use the problems from the assignment. So that's part that says homework. And I'm just going to do question number 1. Synthetic substitution. Okay, so as of right now, if they give you a function such as this cubic polynomial, and they said, well, what is p of -3? What could you do? Yeah, you simply substitute the -3 into all the x's and simplify. Okay, well, that's one way to do it. Okay, there's another way by using synthetic substitution. Okay, so I'm going to teach this to you. It's kind of cool. Are you ready? Okay, so the number that they're asking us to plug in, -3, is the number that I am going to write in the box. I call it the box, even though it's kind of like half a box. It's kind of boxy. Okay, and then what I'm going to do is I'm going to look at the polynomial and I'm going to write each of the coefficients that are in front of each of the terms. Okay, so what is the number that's in front of the x cubed term? 8. And then what's in front of the x squared term? Whoops, sorry. 7. And then what's in front of the x term? 2 and 4. Okay, so I'm leaving a tiny bit of space. Okay, and then I'm going to draw this line. Make sure you leave yourself a little space between the numbers and the line. Okay, so what you do is you take the 8, the very first number that's after the box, and that 8 is simply going to go straight down underneath the line. Okay, now any number that goes underneath the line gets multiplied by the box number. So what is 8 times -3? -24. So that's going to go into the next little slot underneath the next number. Okay, and now what I'm going to do is I'm going to simply add the numbers that are on top of each other. So what is 7 plus -24? What? -17, there you go. Okay, and then now -17 is below, so I'm going to multiply -17 times -3. So what's -17 times -3? What? 51. Okay, then I'm going to add straight down. This just becomes a little pattern. So it's 2 plus 51, 53. And now I'm going to multiply 53 times -3. 159. Yep, you're right. And then add, what's 4 plus -159? -155. Okay, so guess what the answer to this is. If I was going to take -3 and plug it into the polynomial, the answer would be -155. So p of -3 is equal to -155. Isn't that cool? Like, who sat around and was like, I know what I'm going to try. Let's do this. I don't know. He or she noticed a pattern, and I don't know. One day, was sitting in a field with Fernanda the bull. Okay, so let's do one more. Make sure we got this. Okay, so let's do number 2 here. Okay, so we're still finding p of -3. So what number is going to go into my box? negative 3. So I'm going to take negative 3, throw that in. So you could technically find your function of any value. Okay, what are the numbers that are going to follow here? 1, 6, 7, negative 25. Okay, so what do I do first? Okay, after I draw a line, drop the 1, right? So whatever is first, I drop. So I drop the 1. So what is 1 times negative 3? Negative 3. And what's 6 plus negative 3? 3. And then I multiply. What's 3 times negative 3? And 7 plus negative 9? Negative 2 times negative 3. Negative 25 plus 6. So P of negative 3 is equal to negative 19. Look at how fast that is. Just rock that out and like.
Well, I mean, we didn't have 53 there.
Yeah, when they're not giant numbers, it's not too bad. So that's pretty cool, right? All right. Okay, so here comes the dividing part. Okay, so the first division of polynomials is through long division. Okay, so before I go back and do the polynomials, I want you to remember something. You guys remember doing long division back in the day?
Unfortunately.
Okay, so like for example, if we had like 2,438 divided by 3. Okay, you could use long division to figure this out. Okay, you'd be like, okay, 3 goes over here, and then 2,438 goes here, right? So let's erase this, get it out of the way. Okay, so then you're like, okay, well, 3 goes into 24 8 times, so you put an 8 up here. And what's 8 times 3, right? You multiply it through 24, and then what do? Then you subtract, right? So what's 24 minus 24? And then what do? Bring the 3 down, and then what do you do from there? Okay, so 3 goes into 3 1 time, so that goes upstairs. And then what do? So then you multiply 1 times 3, and you get 3, and you subtract, kind of weird numbers, and then you get 0, and you drop down the 8, and 3 goes into 8 twice, and 2 times 3 is 6, and 8 minus 3 is 2. Okay, so at this point, okay, so naturally Miss Nolte wants a fraction, right? So do we all agree that this 2 is the remainder? Remember in the past, and maybe your teacher said, oh, we're going to do remainder 2. Did you ever do that? Yeah. I really hate that they do the remainder 2. Does the remainder 2 even mean anything? It's like completely irrelevant to anything. So did you know that you can take the 2 and simply write it over the divisor of 3, and so that is the exact value?
But
It's a fraction?
that makes sense. That makes a lot of sense.
I'm telling you, since day one, I told you fractions are
You need to go
easier.
teach like third grade.
I know, right?
Like go teach third grade.
It's
Just so
unbelievable.
that-
Like one day,
Kids
Chloe,
understand.
I will teach you everything you need to know. One day. Let's
Yeah,
go.
like why didn't they just teach us that instead of like remaining?
I don't know why they don't show you that. I have no idea. But they should. I should go back and tell our teachers that.
Like high school field day.
Yeah, it's a good idea. Okay, so we are going to do this now with polynomials,
Oh no.
and I'm going to tell you that the process is exactly the same.
That's a lot of numbers.
We just are dealing with x's as opposed to numbers. Well, there's numbers too, but okay. So this piece right here, by the way, is the dividend right here. This one is the divisor. Okay, so the divisor goes in the front, so it's going to be x squared minus 4, and then The divisor goes underneath the boxy thing. I don't think that technically has a name.
No.
We should just call it a boxy thing.
Oh, a house we said upstairs.
Oh, a house. Oh, I like it. Goes inside the house. And that kind of sounds like pretty tough, too. Anytime we can make math sound tough, that's good.
Jail.
The jail. All right, you guys ready?
No.
Everybody have this written down?
Not quite.
I'm never ready.
No, you're ready.
No.
Ready? Okay. So when you're dealing with polynomials, you're going to start by looking at the first term of your divisor and your dividend. Okay, so I'm looking at this x squared and the 18x cubed. Okay, so all I'm going to say to myself is, what do I have to multiply x squared by to make it 18x cubed? 18x. Everybody got the 18x? So that goes on the top. 18x. Okay, now what am I going to do with the 18x? Multiply it through. So what is 18x times x squared? 18x cubed. And what is 18x times negative 4? Ooh.
Oh.
62. What is 18x times negative 4?
Negative 72.
Huh?
64. Negative 72.
72? Negative 72. So do you see what I'm saying? So I'm multiplying 18x times negative 4. So it's negative 72x. Okay, so you see that the x is way over here? I'm going to write my x. I'm going to make sure I line them all up. Okay, x squareds go under x squareds, x's go under x's. Okay, so now what do I do?
Negative 3x squared.
Okay, so now I subtract, right? Okay, so what is 18x cubed minus 18x cubed?
0.
0. And it should always be 0, right? Because we should be, that's the whole point of how we came up with the number in the front. What's negative 3x squared minus nothing?
Negative 3x squared.
Negative 3x squared. Okay, what is x minus negative 72x?
Negative 71x.
Ooh, be careful. X minus negative.
Oh.
Oh. Wow, that was like a collective oh. I will tell you guys that the place where you make mistakes on long division is subtracting.
This is already stupid.
Okay, so just be really careful when you're
I
subtracting.
already felt like this. So a negative.
Okay, so I drop my next term, which is the minus 1. Okay, and I just do this again. So now I'm looking at x squared up here at the top. Hold on, let me change my colors. X squared, and I'm comparing it now to that number out below, negative 3x squared. Okay, so I say, oh, what do I have to multiply x squared by to make it negative 3x squared?
Negative 3.
Negative 3, so that goes up on the top. So negative 3. Okay, so now I'm going to multiply negative 3 through. So what's negative 3 times x squared? Negative 3x squared. What's negative 3 times negative 4? 12. And make sure you line your 12 up underneath the constant. And we're going to subtract. So how many x squareds do I have? 0, okay. What's 73x minus nothing? 73x. And what's negative 1 minus 12? There you go. All right. So at this point, is it possible for me to multiply x squared by something to make it 73x?
No.
I would be losing an x. That's too small. So what do you think the 73x minus 13 is?
It's going to go over the x squared minus 4.
Yeah. Okay, so 73x minus 13 is your remainder, so we write it with a plus sign in the middle of it, and then we're going to do 73x minus 13 over our divisor.
Yeah, otherwise I'd be
Yeah.
like, how did you do that? Why did
Or
you do
why
that?
is it even relevant?
This is why
Yeah.
fourth grade math is kind of important.
This is why teachers need to rethink how they're teaching this.
Yeah, I should go back and see.
Yeah.
Just one day, I'm teaching them to divide correctly.
I should make a little note to myself about that. When do they teach long division? Who teaches it?
Especially if you have less patience.
Okay, so let's do one more. Let's do this number 6 because this is a really good example for a specific reason. All right, so we got x squared plus 8 is our divisor, so that goes in the front, and then 6x to the 4th plus x cubed minus 9x plus 13 goes in the house. Ooh, I like that. I like the way that sounds. All right, everybody ready? Hold on, I'll take a drink. Okay, so where do I start? Okay, so what do you have to multiply x squared by to make it 6x to the 4th?
No, 6x, sorry.
Okay, getting closer. 6x squared, there you go, 6x squared. Okay, so now what do I do with 6x squared? Multiply it through the divisor. So 6x squared times x squared is 6x to the 4th. And then what is 6x squared plus 8?
48x squared. But there isn't an x
Wait a
squared.
second. There's not an x squared on my dividend piece. Okay, so this is what we got to do. We need to have a placeholder for every single term. So what I'm going to do is I'm going to erase these terms. Sorry for having to erase. And I'm going to put a 0x squared in as a placeholder because it needs to have a place, right? And then minus 9x plus 13 after. Okay?
Just like add it in there.
Well, I think that it's important to keep it sequential and everything lined up. Because if you don't line things up, you're probably going to make mistakes. Okay, so what did we say? 6x squared times 8 was 48x squared, right? So we need to put this 48x squared right here. Okay, now what do we do?
Subtract.
Subtract. So how many x to the 4th do I have? Go away. How many x cubes?
Negative or just one.
Just the one, right? And then what's 0x squared minus 48x squared? Good. Oh, you guys are never going to make another subtraction mistake ever again.
Oh, I learned
Dun,
that.
dun, dun. Okay, and then drop that 9x. Okay, so now we do it again, right? Okay, so I'm going to take the x squared and compare it to that red x cubed. And what do I have to multiply x squared by to make it x cubed? So I have plus x up on top. And I'm going to multiply that through. So x times x squared is x cubed, and x times 8 is 8x. Okay, so when I subtract, my x cubes go away. How many x squareds do I have? Negative 48 x squareds. How many x's? Careful, careful, careful. Negative 17, there you go. Negative 17x. Okay, and we're dropping our last term. We're almost there. Got to do it again. Okay, so now I'm looking again at the x squared and comparing it to negative 48x squared. What do I have to multiply x squared by to make it negative 48x squared? Negative 48. So it's going to go up on the top, negative 48. And I'm multiplying negative 48 all the way through, so what's negative 48 times x squared? And what's negative 48 times 8? Ooh. 384, is that right, Lily? Nice. Okay, so when we subtract, my x squareds go away. How many x's am I left with? Negative 17 x's. And what is 13 minus negative 384?
Negative 309.
Ooh. Yeah, it's like adding, right? So it's 397. I'm telling you, that subtraction is just killing you. Okay, so what am I left with here? What is that negative 17x plus 397?
Oh.
That's the remainder. So I put a plus sign, remember, in the middle of it. Don't forget the plus sign, because they're each terms. And then I do negative 17x plus 397 over the divisor of x squared plus 8. Wasn't that awesome? That's good stuff. Anybody want one more example? It is very sequential, but it takes a little bit to fully grasp. Aaron, are you asking a question or?
Why do you put it over x squared?
That's how you always put the remainder. You always write the remainder over the divisor. So, who wants one more example? One more. Okay, let's do one more. We can do it semi-fast. Okay, now we're ready for this one. Even though I really hate that they use an example with decimals and we're dividing theoretically to keep fractions. But we'll play their game. So x squared plus 3x plus 0.5 is the divisor. Anybody notice anything right away about our dividend? What? 3 and 3? Oh, true. I cannot disagree with that. But, like, remember the last problem that we just did and how there was, like, that big hiccup? And we had to, like, erase. Yeah, so there's missing terms. Which terms are missing? Yeah, so we're going to write x to the 4th plus 0x cubed. Sorry, that was a bad 0. Plus 0x squared. Now I have my 6x minus 2.5. Goes under the house. All right, ready? Okay, so I'm looking at the x squared and looking at the x to the 4th. So what do I have to multiply x squared by to make it x to the 4th? X squared. Ooh, that's nice. So I'm going to multiply x squared through, and x squared times x squared is x to the 4th, and x squared times 3x? 3x to the 3rd. And 0.5 times x squared. No, I really do not like the decimal, but if they start with the decimal, you can keep using the decimal. All right, so when we subtract, my x to the 4th eliminates. How many x cubes do I have? Negative 3x cubes. And how many x squared? 0 minus 0.5? Negative 0.5. Tell me if I'm going too fast, by the way. Good so far? Okay, so now I'm looking at the x squared and comparing it to negative 3x cubed. So what would I have to multiply x squared by to make it negative 3x cubed? Negative 3x. So negative 3x. So I'm going to multiply that through. Negative 3x times x squared is negative 3x cubed. And negative 3x times a positive 3x? 9x squared. And negative 3x times 0.5. Negative 1.5x. Good. Okay, then I subtract. And my x cubes go away. So now I'm subtracting negative 0.5 minus negative 9. Good. 8.5x squared. And then how many x's? 6 minus negative 1.5. 7.5x. And I'm going to drop my last term for round 3. All right, so again, I'm looking at my x squared, and now comparing that to 8.5x squared. So what do I have to multiply x squared by to make it 8.5x squared? 8.5, so I'm going to say plus 8.5, and I'm going to multiply that through, so 8.5 times x squared is 8.5x squared, and 8.5 times 3x, I think, yeah, 25.5, right?
Yes. Got the point there.
And then 8.5 times 0.5, 4.25. Okay, so we subtract, and the x squareds go away. How many x's? I have 7.5 minus 25.5. Negative, is it just straight up 18, right? Okay. It's like, okay, what about negative 2.5 minus 4.25? Okay, so now I'm down to a linear piece, so that's smaller than a quadratic, so now I'm at my remainder, so my remainder is going to be plus negative 18x minus 6.75 over the divisor of x squared plus 3x plus 0.5. Well, sometimes. So, I'm going to show you the sometimes. Okay, yeah, long division is time consuming. Okay, so the other method that you can use is called synthetic division. Okay, so this is using synthetic division. Okay, so synthetic division is very similar to synthetic substitution, but instead you're actually dividing the polynomial. Now, you can't always use synthetic division. Okay, you can only use synthetic division when your divisor is linear. Okay, so everybody understand what I mean by linear? It's like x plus 2 or x minus. You can't have anything bigger than an x. Okay, so the way this works is I need the number in the box. Okay, and the way I come up with the number in the box is by finding the 0 that would be created from the quantity of x minus 8. So what 0 is created from x minus 8? 8. So 8 is the number that's going to go into the box. Okay, and what are the numbers that are going to follow?
7, 4, negative 4.
7, negative 4.
Negative 400, negative.
Yep. Okay, so I'm just going to do my normal synthetic division, and when I get to the end, things are going to be a little different. Okay, so I start by dropping the 7, and I multiply. What is 7 times 8? 56. And what's negative 4 plus 56? Uh-oh. Yeah, 52. And what's 52 times 8?
416.
416. So it's negative 400 plus 416. And 16 times 8
Is 128.
is what?
128.
28, yeah. And so negative 100 plus 128, 28. Okay, now that is not an answer, right? Okay, if we're dividing polynomials, my answer should be a polynomial, not a bunch of random numbers. Okay, so this is how I'm going to go to the polynomial. Okay, are you ready? Very simple. It's going to be 7x squared plus 52x plus 16. And guess what the very last number is? 28. So what is that? The remainder, very good. So we're going to put it over the divisor. Was everybody able to figure out how I went from those numbers to the polynomial form? Okay. So see how I just pulled the numbers down? So each of these numbers just go in front of each of the terms. Okay. And then I looked at the dividend piece. Okay, so the dividend was x cubed. So if we're taking away an x, dividing out an x, I'm just going to simply lose an x on my first term. So if this is x cubed, this one is going to be x squared, and then I just lose an x every time. That makes sense? Should we do one more? Let's do one more. I'll do it fast. I like the next question because it has an important piece of information for you. Even though I really hate, again, that they're using decimals. Okay, so for number 10, what's the number that goes into the box? Good. Everybody okay with negative 0.25?
Yes.
Everybody good? Okay, what are the numbers that follow? Be very careful. So 8, did anybody notice that there's a x cubed term that's missing? Okay, so we still need a placeholder even with synthetic division. Okay, so we need a 0 for our x cubed piece. So then negative 28.5, negative 9, and 10. Okay, so we can just crack out our synthetic division. So I'm going to drop the 8. What's 8 times negative 0.25?
Negative 2.
Well, think of 0.25 as the same as 1/4, right?
Yeah.
So really you're just dividing by 4 every time. So 8 divided by 4 is 2, so negative 2. 0 plus negative 2? Ooh, what's negative 2 divided by negative 4? 0.5, good. Okay, what's negative 28.5 plus 0.5? 28. And what's negative 28 divided by negative 4? 7. And what's negative 9 plus 7? Negative 2. Ooh, we did this one. Negative 2 divided by 0.5. And 10 plus 0.5? 10.5. So what's my polynomial that's created?
8x to the 4.
Third, good, because it's one less, right?
Oh, yeah.
Then minus 2x squared minus 28x minus 2 plus, ooh, I really hate writing this. This is like against all math rules. A fraction with decimals. Ugh. I'll never do that again. I know, it's a horror story right there. All right, so we're almost done. I got one last example. Still with me? One last concept, I guess. Okay, so why does this become important to us? Why do we want to be able to potentially divide polynomials? Well, it allows us to factor. Okay, so you guys are able to factor quadratics. We did all those factoring quadratics. We did the special cases, and we did the grouping method. But other than that, there's no special tricks other than using division in order to factor. Okay? So what I'm going to do is I'm going to divide this. Can I use long division or synthetic division in this scenario? You guys okay with me using synthetic? Or would you like me to practice long division?
No, no more long.
Yeah, please, no more long.
No more long.
All right, fair enough. Okay, so what is the number that I'm going to put into the box?
Negative 2.
Negative 2. Okay, so negative 2 goes up in the box. What are the numbers that follow?
1.
1, 2.
1, negative 2.
Perfect. Okay, so I drop this down. I drop my 1. 1 times negative 2 is negative 2, and 2 plus negative 2 is 0. And 0 times negative 2 is 0. Negative 1 plus, am I going too fast?
No, it's good.
And negative 1 times negative 2 is 2. and the last number is 0. Okay, now, when you're factoring, that last number, excuse me, is incredibly important. So the last number is the remainder. Okay, the only time a function is factorable is if you have a remainder of 0. Okay, so this is very important. This means our function is factorable. Okay, remainder of 0. Okay, so tell me, what is the polynomial that I just created with those 1, the 0, and the negative 1? What's left over? So it'd be x squared plus 0 x's. Do I need to say plus 0 x's?
No.
Nah, minus 1. Okay, so this is the factor of the polynomial up above. Okay, what I did is I just factored this. So that red polynomial up there that I squared, if I was going to FOIL these ones below, they would be equivalent to that standard forward polynomial. Okay, now am I finished factoring? Can I factor x squared minus 1 further?
Yeah, you can. It's a square, isn't it?
Yeah, it's a difference of squares.
Oh, because we have to go further?
If we can, and in this case we can. So what does x squared minus 1 factor into? X minus 1 and x plus 1. Good. So we have x plus 1, x minus 1. Don't forget your x plus 2 from before. And now that polynomial is fully factored by using synthetic division. That was awesome, right? There's like a lot of big ideas in that section. Yeah.
So like when it came out to 0, you know that's factorable. Like what else like would make it?
0 is the only number. So if you get anything other than 0, then you stop and you say that's not factorable. Has to be 0. Do I need to do one more example of this idea, or are we okay?
We're okay.
Okay. Then I'll let